Hello, calculus friends. I'm going to talk to you a little bit about algebra and arithmetic. So arithmetic. When I hear the word, I think of, addition, subtraction, multiplication, division, and kind of like the problems that my kindergartner does, like 9 plus 2 equals 11. 12 minus 5 equals 7. We're in an interesting spot with her, though, because I'm not sure if someone told her or if she just came up with this on her own, but that, 5 minus 5 is 0, and 5 minus 6 is also 0. But I'm not going to get into negative numbers with her yet. So I found this book about arithmetic that has a nice, pleasing arrangement of a bunch of pine cones and stuff on the front. It's a lot more interesting than I expected, actually. I don't tend to sit around and read math books in my free time. I actually read a lot more young adult fantasy. TBH, if you need any recommendations, let me know. So the key word in this here is comparison. So numbers matter mostly in terms of comparison. So maybe you think of 24 hours being a day. So 30 hours doesn't mean much except that it's, a little more than a full day, for example. Obviously, we care about exact amounts in math because we probably want to get the number right. It's also interesting to think how brains are better at counting with patterns. So if I give you this kind of array and you look at it, you can kind of group it together and say it's 6. But if I gave it to you like this with 3 groups of 2, you'd probably know without thinking at all that it was 6. This is one example in the book. Maybe it's just not that hard to count to 6, so maybe both of them work. I don't know. Representations versus actual things is another piece to think about. How we tend to count by 5s because we have 5 fingers. And that's kind of where tally marks being 5. So 1, 2, 3, 4, 5. 2, 3, 4, 5. It's pretty quick to say this amount would be 5, 10, 11. But if I just did this, glancing at that, I would probably have to count somehow. I might say it was about 10, but would I get 11 just looking at it? Not without counting it. So brains, again, are better at counting with patterns. So there's a lot in this book, too, about kind of the history of math and how people counted and how people started counting and kind of where money comes in and things like that. So I kind of like, for example, that's not a Y, that's a U. Egypt. They counted like this. This was 1, this was 2, etc. This was 8. 9 was 1, 2, 3, 4, 5, 6, 7, 8, 9. And then there was 10 also, which they decided to just make this. As arbitrary as anything else, I suppose. So if you wanted to write 45 using this type of arithmetic, you would say 10, 20, 30, 40. 1, 2, 3, 4, 5. So not quite as efficient as our numbers, but work just as well. All sorts of different regions did different things. Again, the book is actually fairly interesting, shockingly enough, so I kind of recommend it. I like this quote. Of course, being a mathematician, I'm always looking for ways to avoid tedious, mundane labor, especially if it means I get to do a bunch of interesting abstract thinking. That's kind of the whole math thing, working hard to find ways to get out of working hard. If you're really, really lazy and also happen to be really, really clever, then math just might be the life for you, assuming you also have no interest in wealth, fame, or popularity. So, there you go. The Arithmetica, which oddly has a lot to do with algebra versus arithmetic, but don't worry about that. From the 3rd century A.D. I read about that in this book. And by read, I mean skimmed. I'll be honest with you, this is a really long book, but interesting. I'm pretty sure my husband's read the whole thing. He has it. So God Created the Integers by Stephen Hawking. So the Arithmetica is a big book of algebra problems. Like this. Given one number, to find 3 others such that the sum of any pair of them added to the given number gives a square. And also the sum of the 3 added to the given number gives a square. So I'll let you just, do that on your own time. It's a tricky one. I find it just crazy that tricky algebra problems have been around forever, since like 200 something AD. So in terms of algebra classes, you guys had taken Algebra 1, or I don't know, maybe it was called one of those trans math ones, I'm not sure, but Algebra 1, Advanced Algebra. College Algebra is another course. It's offered here. I pulled this description, both of these actually from the U of M's website, or one of them. College Algebra kind of goes on from what you learn in high school, which makes sense. Linear Algebra is one I'll talk about in a little bit. General Algebra. I mostly included this one because it made me laugh, because it's called general. But who hasn't heard of the basic Wedderburn theory of rings? I haven't. Maybe Miss Stone has. You should ask her. So, linear algebra. So just a very short stories, not right, anecdote thing I'm going to tell you, regardless of whether you want to hear it. I found that every advanced math class I took, you would get into it, and then suddenly you would realize that you were talking about systems of equations again. So, systems of equations are important, and they come up all the time. Linear algebra is the study of vectors and linear functions. That's one definition. So, for example, not sure if you guys know about vectors. You might not. But in general, this would be a vector. And you could add it to another vector. And you would essentially just add across. 1 plus 0 is 1. 1 plus 1 is 2. 0 plus 1 is 1. You can multiply a scalar by a vector if you feel like it. So 3 times 1, 1, 0. 3 times 1 is 3. 3 times 1 is 3. 3 times 0 is 0. You can also represent systems of equations with vectors. So let's say you have the system of equation 2x plus 6y equals 20. 4x plus 8y equals 28. So you could represent this with vectors. You could say x times 2, 4, plus y times 6, 8 equals 20, 28. You might hear my screaming child in the background. Please disregard. She's totally fine. I've said this in a bunch of my videos, if I teach you all the time, so, it's all right. Screaming children are a part of my life right now. You could rewrite this again as 2, 6, 4, 8 times xy equals 20, 28. So that's like a very basic intro to how systems of equations are used in linear algebra. So there you go. Have a great day.